So let us start our live session. Well, I hope so that I am live. I hope so that I am audible. I hope so that I am visible. Hey guys, welcome back to Coders Arcade. This is Ashank David and welcome to our session number 30 of daily DSA live session, all for free. Now, in this today's live session, we will continue from the previous live session where we have left actually in the previous live session, and we will see what all things we can do in today's class. Welcome everyone who is new into this channel. Please do like, share and subscribe to my channel Coders Arcade, and don't forget to press the bell icon also so that you won't miss any future updates. Apart from this, try to share this live stream as much as possible guys, so that those people who don't know about that a free DSA live session is going on, they can also attend this live session. Without any further ado, I want to get right into the concept guys. Today's concept is gonna be mostly the code implementation. The code implementation of heap data structure. And in today's video, I am gonna explain you the whole code line by line. Alright guys, let us start, and let me just put up the, I'll just press the camera button so that it doesn't go off, because again, as you know, I am the only one who is managing the camera as well. Okay, so guys, let us start. Without any further ado, let's, yay, 30 sessions, yeah. Vivek Raghuvanshi, yes. So we finally came to 38th session. A lot of, it has been 1 month guys, and we have reached till heap data structure. Yes. Well guys, after this concept, I am going to start directly with the graph concept, and in between if there is anything, I will definitely cover all those things also, so don't worry about it. Okay, graph sessions will be the most important sessions, and yeah, so we will talk about that. Okay, so yeah, without any further ado, let's get right into the concept. Okay, so in the last session guys, what did we understand? We have understood about the heap data structure. Heap data structure. Very nicely we have understood about this. Everything was told and explained in depth. So if you have any doubts, or if you had any doubts from the previous session, please do let me know. Speaking of Vivek Raghuvanshi, have you watched all our videos till now? Are you in sync with me in this till this video? All the 29 videos I've done, or you have skipped something? Let us see. My question to Vivek Raghuvanshi. Yeah. Yeah, so let us continue guys. So here, we have done heap data structure explanation. I have explained you very well. Let me just revise it. Heap data structure is just a binary tree data structure which allows us to store the data and do some operations onto that data. What kind of operation? Majorly extract operation. What happens in heap? Heap looks like a big pile of something, and in this big pile of something, the element which has to be extracted is always at the root. So this will be extracted. We have understood this, that let us say this is 100 needs to be extracted. This is gonna be root. Root will always be extracted. So in this case, the time complexity for calculating the extraction process is going to be O of 1 time complexity. I hope so that this is very much clear to all of you, very much clear to all of you. Correct. We have understood this really well. Major thing was that we are trying to implement a priority queue. Ultimately, we are trying to create a priority queue. Okay. So that is what we have done, and all the explanation is already been given into the code. Now in the previous video, now in this video, in this session, I am going to explain you the code line by line. Okay. So let us move on, and what all operations we have, we are going to see the insertion. So I am going to say insert, then I am going to say delete. Okay, these are the two major functions that we are going to see. Okay, and one more thing, heapify. Heapify is also very important, guys. In this program, there will be terms like heapify up. Remember this, heapify up. Remember this for later purpose. I will explain you what exactly is this. Heapify up, also called as bubble up, B-U-B-B-L-E-U-P, bubble up. Then we have heapify down, also called as bubble down. Heapify down or bubble down. Actually, if we talk about this, then these are the major functions that we are going to see across. Heapify up, heapify down. Now, if I'll explain only heapify up, and why, I'll explain you, I'll tell you why I have used it. Okay, let us move on to the code. Let us start, guys. As in yesterday's class, I have explained a little bit of the code. What is happening here? Class max-heap I have created. Okay, class max-heap I have created. Inside this, because we are doing the array implementation, so we have taken an array pointer. So int star arr, we have to allocate the memory to it. To allocate the memory, later on in the constructor part, I will do it. Then we have int max size. This max size is the maximum size of this array. Understood this? This max size is the maximum size of the array which we are using for creation of heap data structure. Then we have heap size, which tells us the current number of elements present into our heap. Understood this? Then these are some helper function. Yesterday I have explained you this. When we are trying to create a heap data structure in an array, the parent is denoted by I, and the formula to find parent is I minus 1 divided by 2, and if you do this, you will get its parent in the terms of array. Got it? If you want to find the L child or left child, in that case the formula is 2 into I plus 1. And if you want to find the right child, then the formula is 2 into I plus 2. So these three things you should always remember. Whenever you are working with heaps data structure, this will be there. Okay. So now these are the three helper function, and you observe one thing, that we have not mentioned any access specifier in the code, which means that we are still in the private section of the class, maintaining abstraction. For those people who don't know what is abstraction, I have already created a video on the whole object oriented programming of C++. There is a whole playlist for 5.5 hours. In that 5.5 hours, there are 5 videos, and if you watch that last session of that 5 videos, the 5th video if you see, at the very last I have explained what is abstraction. What is abstraction and what is encapsulation. So please go ahead and watch that if you don't know what I am trying to explain here. You getting my point, guys? So in this case, we are trying to do abstraction. Maintaining abstraction in the program is very much important, guys. Remember this. Okay. So we have int star ARR, int max size, int heap size. Then we have int parent, int L child for left child and R child for right child. The formulas for all of three of them are I minus 1 divided by 2 for the parent finding, and 2 into I plus 1 for the left child finding, and 2 into I plus 2 into for right child finding. I have explained this concept very well in too much of depth in the yesterday's class. So go ahead and watch 29th session, then I have explained you exactly how you will take out and derive these formulas. So if you are new to this channel and you are wondering how the hell, 29th session, session number 29, in depth I have explained. Later on you can watch, but right now, for the sake of understanding this example program, always remember these are the three formulas. Okay, in simple and short language, in simple and short way that you will understand. Okay, this is void heapify function. This is the main thing right here, which we will talk of about later on. So don't worry about it. We will talk about this later on. Okay. So don't worry about this. We have kept it for the later explanation. When the use of it will come, I will explain you how it will be used. Okay. So now starts the public section of the class. Here in the public section of the class, we have started by creating the constructor. Now as you can see, the class was max-heap and our constructor name is also max-heap, because constructors will have the same name as the class name. If you don't know what I am trying to say, go ahead and watch my session number 2. Session number 2 of object oriented programming, mastering C++ object oriented programming for placements for DSA, a separate playlist for 5.5 hours. Go watch session number 2. I have explained you there. Clear? Understood? So max-heap is the constructor. What are constructor? You already know by now. If not, then go ahead and watch that video. Then in this case, this is the constructor. With the help of the constructor, we are initializing the max size of the, what was the max size? The array size, the array size. Remember this, guys, the array size. There were 3 elements. Number 1, the array. Number 2, the maximum size of the array, and number 3 was the heap size. So first one, array, which was empty, where we did not allocate the memory yet. Now in the constructor we will allocate the memory, and then comes your maximum size, which is the maximum size of that array, which we will use to allocate right like this. I will explain you. Okay, and then comes your heap size, which is gonna be the number of elements. So in the constructor, I have taken up the parameter. This is a parameterized constructor, guys, and in the parameter I have taken the max size itself as the parameter, which tells us the size of the array, the size of the heap, the maximum size of the heap. That means we know the limit of the heap, till where we can go. Understood this very well. This of max size equals to max size, everyone knows this if you have watched my object oriented series. Initializing the maximum size, because for later on when you will start writing the program in the main function, what you will do? First you will create the object of the max heap, and when you will create the object of the max heap, there you will have to give the size of the max heap, of course. I hope so that this is also very much clear. Now initially there are no elements into the heap. So heap size was the variable which we have created for telling that heap is empty or heap is full, or how many elements are there into heap. So right now, because there are no elements, heap size is set to 0 initially, and with the help of the constructor we have done this. I hope so that this is also very much clear to all of you. If you have any doubts, please do let me know in the chat and I will solve your doubt. Next up, we have the array. array was not initialized with any space. You see in the right here in the line number 6 right here, you see that this array is not initialized. We have just declared it. It is a pointer to an array representing the heap. Later on in the public section of the class, we are allocating it some memory using DMA, dynamic memory allocation. Those people who don't know about this, go ahead and watch my session number 2 of DSA live placement series, the same playlist. Go there and watch video number 2, session number 2. You will understand what is DMA, dynamic memory allocation. Using the new keyword, we have allocated the memory dynamically with the max size value. Everyone knows how to do this. Okay? If not, then go watch that video. This is the destructor. Not of or tilde symbol of max heap is the tilde symbol of the constructor is the destructor. So, not of constructor means destructor. I hope so that this is very much clear to all of you. Correct? So, in this case, this is the destructor which will delete the array later on. Now, this guys totally optional, it is up to you. It was looking cool, so I wrote it. You don't have to write it because anyways destructors will be called automatically. And when the program gets over, you don't have to worry about anything. Well, this is optional, but for your knowledge purpose, I have written it so that everyone should understand how destructors are also used, because very less places you will understand where the destructors are used, and this question can be asked in interviews, that what is destructors and where they are present, where you can use it, how you can use it and what you can use it for. And for this also I have explained in the session number 2 or session number 3 of Mastering Object Oriented Programming with C++ with Ashank David. Go ahead and watch that video again. I hope so that this is also very much clear. Okay. So guys, I am going out of the camera because again and again I have to press a button so that the video doesn't get switched off. Problem with the camera is that it after some time it automatically stops the stream. So I need to continue the stream. So for that, bear with me. I'll just go out of the frame and then come back again and again. Understood? So till here we all have understood really well. Next up, we are gonna do the insertion, which is going to be the main first step of heap. This is what we are here for today. Insert a new key into the heap. So we have a function called as void insert, and this void insert will take up a key. Key means value, key means value. So you need to give the value, right, of what you want to insert. So later on in future when you will call this function, you will pass the value into the key. Very easy. If the heap size, of course, this is the overflow condition, guys. Remember, if already the heap size is equals to the max size, then this becomes overflown. You know that the array is fully done, like fully filled up till the last element. Last element means max size is the maximum size of the array and heap size is the current number of elements. So if the current number of elements reaches the last index, means the array is full, the heap is full. If heap is full, overflow, could not insert a key or could not insert a value. I hope so that this is very much clear to all of you. Okay, very easy. Now you see what we have done. Now the thing is, imagine this. So we are doing this heap size plus and I am going to take up the index, that is going to be heap size minus 1 and ARR of I. Now what the hell is this what I have done here? Let me just explain it to you right away. Let me just tell something very important, guys. Very important concept. If you don't understand this concept, forget insertion in heap. Forget you have understood insertion in heap if you have not understood what I am going to explain you right now. So listen to this very carefully, everyone. Let us say that this is a heap data structure. Heap data structure. Let us say this is 100, this is 30, this is 50, this is 10 and this is 20. Now not necessary that it is binary tree. or not necessary it is binary search tree. My habit is writing binary search tree, so I have written it, but you don't have to. Okay guys, now listen, now listen to this very carefully guys. If we open the notes, if we open the heap notes, yesterday I have explained this to you that how does the insertion takes place. See, if we insert a new element into the heap, since we are adding a new element into the heap, so it will distort the property. Okay, that is fine, and we need to perform the heapify operation to maintain. Okay, that is also fine. Just wait. We understood this example. If this is the tree, this is 8. For those people who cannot see it, let me just zoom in right here. So let us say this is 8. 8 has the children as 4 and 5, and 4 has the children as 1 and 2. Okay. Now this is a tree. This is a heap, let us say. Okay. Now I want to delete anything, and what I had told you that anything which we delete from the heap is deleted from the top, which means this element will be gone. This 8 will be gone, and when 8 will be gone, who will come there? Okay. This was about deletion. If we are doing insertion, then if I want to do anything insertion here, I am not deleting anything. Let us say this is our tree and this is our heap data structure, and I want to do insertion. How do I do insertion? Let us say I need to insert 10. This 10 I need to insert in this case. Okay, how do I insert? Now where this 10 will go? 10 will go right here as the child of 5. Where do it get inserted? It gets inserted to the, it is given already in the here, where it was, you see 10 got inserted right to the left hand side of the 5. Are you getting my point? Did you see this? So the insertion of any element inside the heap data structure will happen at the last available index from left to right. We have understood this in the last class. Quickly, where it was. See this guys, insertion and removal. New elements are inserted at the next available position at the bottom rightmost level, and the heap property is restored by comparing the elements with its parent and swapping if it is necessary. Very important concept guys. What does the notes says? That insertion, new elements are inserted at the next available position. So if I want to insert 10, where will this 10 go? This 10 will go right here at the next available position from the bottommost left to right. Understood my point? I hope so that this is very much clear. Now you tell me, the property has been distorted? No, in this case the property has not been distorted, but if this was, let us say we were not inserting 10, let's say we are inserting, let's say 120. If we are inserting 120 guys, then of course if it was 10 then it would not distort it, but if it was 120, then yes, it would have been distorted. The what? Heap property. Distorted the heap property. What is the heap property? Either the maximum element or the minimum element will be on the top. Did you get my point? Either the minimum element or the maximum element will be on the top. So in this case, maximum element is, you tell, 120. It should be right over here, and which is not there, which means heap property is gone. In this case, what we will do, how will I maintain the heap property? I will start by comparing this element with its parent element. 120 compared with 150, who is bigger? Swap it. So now 120 came here and 50 came right here. Now you will compare this 120 with the previous, its parent, and then you will swap it until 120 becomes the top element or the root element. So guys, whichever is the biggest will take the seat. I hope so that this is very much clear to all of you guys. This is what heap property says. This is what heap property says. So if we see the code right here, what I have done is I have incremented the heap size. Heap size was the current number of elements into the array, and that was equals to 0. So we have incremented that, so 0 become 1. So one element is updated, and then I went to the heap size minus 1 in any array. Listen to this, because this is array implementation, correct? Let's say this is the heap array implementation. What is the last element? N minus 1. If n is equals to the size, correct? If n is equals to the size, guys, then the last element is n minus 1. But heap size, let us say there is 1, 2, 3 elements are filled here. So what is the heap size? Heap size is this, which is 0, 1, 2. Third element. So n will be 3. So heap size minus 1 means the last index. I hope so that this is very much clear. So last index available position at that time, that place, it will get inserted. And for that reason here, guys, I have taken heap size minus 1, I have stored it into that I, and then I have said this was unnecessary, but to make it more simpler, I have done it like this. So ARR of I equals to the key, and the key will go in that particular index, means the next available index after the last element inside the heap, not necessary being the last space in the heap. I hope so you have got my point. This is very much clear to all of you. Now it might be distorting the property. So as I told you, we will need to swap the child with the parent and child with the parent until that child which needs to go into the top seat reaches the top seat. How? We have written a while loop because we don't know the depth of the tree. So we don't know what are the number of times we need to repeat ourselves into swapping. So for that reason, I am using a while loop and saying that if the ARR of parent of I means what? ARR of parent of I. If I is this, guys, listen to this very carefully, what I am going to say next. Okay, I need to move this 120, I need to move this 120 above, right? So this is, let us take this as I. So ARR of parent of I, ARR of parent of I means ARR of parent of I. Parent of I is this, parent of I is this, and this is child which is I in itself. Understand the point? So in this case, ARR of again, I know you did not get it. Again, we have written battery is running low and now the battery is not running low. Okay. Again let us understand. Guys. We have written, what we have written here? We have written here ARR of parent of I is lesser than ARR of I. Okay, ARR of I. Here you see, this is ARR of I and this is ARR of parent of I. Guys, this is I, 120 is I. So ARR of I is 120, its parent is 50. So 50 ARR of parent of I. Parent of I is this. Is it smaller than ARR of I itself? Yes. When this is the case, then you call swap. Okay guys, you call swap. This is what we have done. If ARR, while ARR of parent of I is smaller, that means 50 is smaller than 120, then you swap 50 and the 120. Swap 50 and 120. Swap 50 and 120 until this 120 reaches on the top. Hope so that this is understood. Hope so that this is very much clear to all of you guys. If not, then please tell me in the comment section, I'll solve your doubt. Okay guys? Acha, apart from this, one thing I told you to remember in the very beginning of the class, and that was heapify up and heapify down. Heapify up and heapify down. Just now what we have done here, just now what we have done this is what you called as heapify up. Heapify up means we are trying to maintain the BST, like not BST, heap property by just editing that branch of the tree. We are not bothering about any of the other subtree. We are bothering only about that depth. Only this is depth, because I know that in this position the element was inputted. Guys. This process of maintaining the heap property is what you call as heapify up, or we call it as bubble up. Why bubble up? Because now this 120 is moving up and up and up and up and up till it reaches the root node like a bubble. Bubble up that particular element which needs to sit on the root. This is what you called as heapify up, guys. I hope so that this is very much clear to all of you. If not, rewind the video and watch it again. No time to repeat the things again and again. This is the power of YouTube, guys. If you have any doubts other than this, please do let me know in the chat window. I can see your chats right live in front of me. Got this guys? I hope so that I am audible as well. Apart from this is what you call as heapify up. Now the same thing if you are doing in downwards is what you call as heapify down. Guys, you might ask me, why sir you did not call heapify function? Wait for that, I'll tell you when the time comes. I hope so that insertion is over, and insertion you have understood it very clearly, guys. That just check for the overflow condition, increment the heap size, go at that available index. How? By going to heap size -1 and then inserting that key at that ARR of I and hence doing the job. Okay, and then this is how you do heapify up. This is clear? Alright. Next, we will see the extract max or extract minimum, depending upon you have max heap or you have min heap, guys. Okay, let us understand. Int extract max. Why we have taken int here? Because it is going to return us the root value. Of course, if I want to, you already know, right, guys, that whenever we are extracting the element from the heap, the topmost element gets deleted from the heap, because that is the element which is going to get deleted with the time complexity of O of 1. I have already explained you this in the previous live sessions. Got it? 100 times I have explained you, 2-3 times I have explained you. By now, if you are watching and listening to me very carefully, you might have understood this already, that whenever we are trying to extract an element, that element gets deleted by O of 1 time complexity. How? Because it is sitting on the top of the heap. And whenever you pick up anything from a pile or a heap, you always extract the first element which is sitting on the top. And hence the time complexity becomes O of 1, big O of 1, which is imaginary case, but in the worst case you are getting it. This is the reason why we use heaps as the priority queues, because the highest priority element is kept on the top, or maybe lowest priority depending upon your ascending order priority queue, descending order priority queue, max heap or min heap respectively. I hope so that this is very much clear to all of you. See how deep I am talking to right now, you guys right now. If you watch and listen to what I am saying right now, you will understand what I am trying to explain you. But if you have not watched our previous videos, if you don't know the basics of C++ and what I am trying to say here, then it becomes very difficult. So if anybody is new here in this session, I would highly recommend you guys to please go ahead and watch our basic videos first and then come to this point, because then you see why people start hating DSA. Why? Because they directly start with DSA, they don't do the foundation stuff, and when you don't do the foundation stuff, you know that you will start hitting a subject. And my camera went off. It is back now. Alright guys, I hope so that this is also very much clear in my videos. Understood this? Now speaking about extraction, we know this that extraction, if I want to extract any element from the heap, if this is the heap, then always the topmost element, this will get extracted. And in terms of an array, if you are trying to extract any element from the root is always kept right here at the beginning. So that means the first element needs to get extracted, and for that it is very simple guys. Check if the heap size is lesser than or equals to 0. If it is lesser than or equals to 0, then it is empty. See, you can return here int max, int min, or maybe -1. You don't have to worry about what I have written here, numeric limits, and this is a fancy thing. You can just write return -1. No worries, it will also be correct. Guys. Say return -1, clear. Don't have to worry about that. I hope so that this is very much clear to all of you. Right. Now we know this already that the root is kept at always at the first index, that means ARR of 0. So we took the root from ARR of 0 and we just stored it, we just made a copy of it. Why we made the copy of it? Because the next element, we will replace that element with the last available index. Guys, you see that how will I delete a node? How will I delete a root? If I delete the root, all the elements will be distorted because the first element will be empty. So what I will do is, I will take the leaf and I will copy the leaf in the position of root, and I will ask all the elements to take 1 1 1 1 position back in the array, and that will be it. How? Very simple guys. If this needs to be deleted, let's say this is 1 2 3 4 5. If this needs to be deleted guys, then I will ask 5 to come right here. So 5 came right here, and if I want to delete 5, now I will say just last element get deleted. Heap size minus, heap size minus, and this is how you delete it. I hope so that this is also very much clear to all of you. If not, then please do ask in the live chat, as you can see already. Okay, absolutely clear to all of you. Now guys, this is what we have done. You see right here, root we have taken, and in the place of that root, we are saying, in the place of ARR of 0, I said that ARR of heap size -1 means the leaf node, the last element, the leaf node, you get replaced by the root. And once this is done, heap size minus, that means the last element gets deleted. And then in this case guys, you have distorted the whole tree. In this case guys, you have distorted the whole tree. Let us see this example. You have a tree. For example, we have 8, we have 3, we have 1, we have 2, we have 5. This is our heap. Now I want to delete, extract. Extraction will always make sure that the root is deleted. This will be extracted. But the problem is that this, if this gets extracted, this should not break. Understood my point? So for that, what I will do is, I will take this 2, and I will bring this 2 right here. So 2 will become the new successor of the root. 2 is the leaf node. I'll say available or next available leaf, or you can say last available leaf node. You can say last available leaf node will replace the root with itself. Are you getting my point? And when this happens, now there are 2 duplicate values which cannot be possible. So what do? You delete this. Done. Deletion is done. 8 is deleted. In the place of 8, 2 came. Now 2 became the new root and 8 is extracted. While you did not even destroy the whole tree, you just created a new tree. But guys, there is one issue. You have done all these things. But there is one very big issue. What is that issue? Now heap property is distorted. There is no heap property maintained. If you see, this is what? This is 2 from the leaf, right, which you have recently added. Is it maintaining the heap property? No. In heap property, according to the heap property, 5 should come over there and 2 should go over here again. I hope so that this is very much clear. Guys. Yes. That means now in the case, here we will call heapify. Finally, we have come to this point of time where we are talking about heapify. So what is heapify? Why I am calling heapify? Why did not I do bubble up or bubble down in this case, you might ask? Because we don't know. We don't know from which branch the root was taken. In this case, from this branch, the root was taken and put up right over there. But it could be possible that this branch was not connected to this branch, but this branch was connected to this branch. This also could have been possible. Then you don't know which branch was the successor or which branch to be specifically bubbled up. Are you getting my point, what I am trying to say? Or understand it like this. Let us say that it was here. Okay. Now I am saying that you don't know right now who will be the right heir of the root or right successor of the root of the thorn. Understand my point? Who will be the right successor of the root throne? Understand my point? This is Game of Thrones. So what happens here? We will call the heapify. Heapify will check all the branches. Heapify will go down here, it will go down here, it will go down here and check, oh, this guy is perfect. So make this guy the new root and bring this guy, make this 2. Now the tree is perfectly balanced and maintaining the heap property. This is how you maintain the heap property. So you guys need heapify. The difference is heapify will go in every branch. Heapify will go in every possible branch. Understand the point? But heapify up or heapify down, they will go in only one direction. Only one direction, because in that you know which direction you have distorted the tree from. But in the case of extraction, any node can be the successor out of the whole tree, and in this case you need to find that successor, and to find that successor heapify has to go down to every depth of the tree. Clear, guys? Understood this very well. And this is how you need heapify function. Okay, enough of that. Let us understand what is heapify and how the code was written. So you see that after calling everything, heapify of 0 to restore the property starting from the root, we call the heapify function and we pass the current element from the root. The root element is heapify 0, 0th element, no. So we passed this. So here in the private section in this class, I have written heapify function. See, first of all, if I am calling the heapify function should know which element has to be heapified, and it needs to find its left child and right child, and my camera went off. If you want to find someone a right person who will sit on the throne, then you need to find its left child and right child and ask who will be the successor of it. For example, in the case of this example which I have explained, in the case of this example guys, where 2 became the new successor from the leaf node, this was the case. Now, which one is the right successor? For that, if this is I, then I need to find the largest of its left child, its right child and itself, because whichever child is going to be stronger, whichever child is going to be stronger, whichever child is going to be bigger will be the right successor of that parent or the root, correct? This is the story of life. This is the story of life. This is how biology works. This is how humanity works. The story of life says that whoever is the successor, whoever is the largest, whoever is the bigger, whoever is the strongest will be the right successor of that particular throne. Understand my point? So, in this case, 2 should be compared with 3 and 2 should be compared with 5. Understood my point? So, 2 should be compared, 2 right now is the parent. Parent should be compared with L child and parent should be compared with the R child, right child and left child. And to do it, first of all, you need to find the left child and the right child of 2. And we know this from the formula that we have created right over there above, that 2 into I plus 1 is the left child, 2 into I plus 1 plus 2 is the right child, and itself parent is going to be I plus 1 divided, I minus 1 divided by 2. Got this guys? Okay. So, int L, first of all we found its left child. So, whatever we want to heapify, that we took heapify of I, and I said L equals to L child, left child of I, and then R equals to R child, means right child of I. So, right here from these two functions we will get the right and the left child, and once we have got the right and the left child, we took a variable called as largest, and we already know how to find the largest of 3. How do we find the largest of 3? Right now we are assuming that the I itself, 2 itself is largest. For example, we are just imagining that 2 is largest. In the initial stages we are saying that let us say 2 in itself is the largest. Okay. First I will compare the ARR of the left child. The left child is greater than the parent itself or not. If the left child is greater than the parent, then left child will be largest. If 3 is greater than 2, then 3 will be, see right now I am taking largest as equals to 2 initially. Now 2 will be compared with its left child is 3. So, is 2 greater than 3? No. So, largest became 3, the left child. Understand my point? And now this left child will be compared with its right child. So, whoever became largest of this, if this was largest, then this would have been compared with this. If this was largest, then this would have been compared with this. So, that is why the largest of I, whoever is the largest is 3. So, largest will be compared with the R right child. Understood this concept guys? So, first compare it with left child, whoever is largest, that will be compared with this, and hence you will get the largest, which will be the successor, which will be swapped up there in the heapify function. Understand our point? So, largest is taken as L, and you see, because if the left child is greater than the right child, then left child will be largest. If whoever is the largest next, if right child is largest, larger than the previous largest, then right will become, otherwise largest will remain largest. This logic is clear. If not, then slowly go ahead and watch this again, this iteration. You will understand this, guys, don't worry. Okay. Now once you have found the largest, if largest is not the parent itself, if largest in itself is the parent, then do nothing. Let the parent be sitting there. That means it has not distorted the element, distorted the heap property of the array. But if it is not a parent, if it is not I, then you swap the I with the whatever was largest and call the same function again with that largest. Recursion, guys, recursion, because this is trees. And let us say who was largest? 5. So we swap the 5 with 2. So now this 2 goes here and 2 comes here and 5 goes right here. Is the heap property maintained? We will check. We will call again the heapify function again with whoever was largest. That means again the heapify function will start from 5. Checking if left child is largest or right child is largest, parent itself was largest, so nothing will happen and the iteration will get over until this happens, and you see that the heap property is maintained now and this tree is already maintained. I hope so that this is very much clear to all of you. This is heapify function, guys. Well, any doubts? If any doubts, please do let me know. Okay, that's it. This is your heapify function. I hope so that this is very much clear. Heapify function means compare it with the left child, compare it with the right child, whoever is largest compare it with the right child. Now whoever is largest, you swap it with the I, and if the parent itself is largest, then do nothing. This way you will be able to compare each and every element, and in this case you will be able to heapify up the heapify properly. I hope so that this is also very much clear. For any doubts, please do let me know in the chat, in the live chat. Let us move on to, this is extract is over, insert is over, extract is over. Okay, now we will see what is this increase key. I'll tell. Let us say delete. Very easy. Very easy, guys. We will see delete. We have delete key. Okay. When if I want to delete, let us say I want to delete this one I want to delete. Let us say one I want to delete. So what I'll do? I'll say increase that with int max. Increase that one with the maximum possible value. Increase that one with maximum possible value. Why? Guys, this is maximum heap, and if you want to delete anything, use your brain. If you want to delete anything, just increase the level of it so high that when you call the heapify function, what will happen? That element will come over on the top if that element is largest. If you want to delete if you want to delete 1, then make this infinite stronger, infinite large, because whatever is there in the root cannot be as large as infinity. Did you get my point? And then call the heapify, and when you call that heapify will keep this 1 right over the top. 1 will come right here because it is now infinity. Understand my point? And then call the extract function. Understood how easy it was? How easy it was, guys. Delete. How easy it was. To delete anything, increase the priority or increase the level of that particular value to infinite or whatever possible maximum value it is. And that will automatically come on the top after heapify is called. And once it is done, just call the extract function and it will do the job for you. I hope so that this is also very much clear. Quickly let's see the code. Delete key We said increase the key of that particular key with int max. Int max, everyone knows, the maximum possible value an integer can hold, because this value cannot be as larger than the root value. Understood? This is the function increase key which I have written. So increase key, what we have done? We are taking that particular key and we are taking a new value through which we want to increase it. Now in this case I have passed two things, I and int max. Int max will go into this new val, and I in itself is 1, let us say, for example. And I said ARR of I means that one will be replaced by a new value which is int max. So I became infinite, like 1 became infinite. And when 1 became infinite, what happens? You just bubble it up or heapify it up, because you know that only that particular branch you have distorted the heap. So for that, what do? You just heapify that particular branch, and when you do that, what will happen? The 1 will go over on the top, and once that 1 goes on the top, you call extract max. Extract max is already extracting, and it in itself it is heapifying it. We have already understood this, guys, really well. This is how you do heaps. Very important data structure, guys. Heaps are absolutely important, freaking important data structure. If you have not understood heaps, forget about doing graphs, Dijkstra's algorithm, Prim's for MST algorithm, Kruskal's algorithm. All of these are what? Or maybe DFS or BFS in the graph algorithm. All of this is what? Uses priority queue. And the best priority queue can be heap data structure. This is the story of heaps, guys. I hope so that this is very, very much clear to all of you. You people are sitting there, but you people are not speaking anything. You people are not doing anything in the chat. I am just looking at an empty chat box here, and no one is saying anything here. I guess you have understood the whole concept, guys. Then I can just close this live session. If you don't want the doubt session also, I can close the live session. But I have completed heap concept today, with the code explanation, with the tracing, with the dry run, with the whole thing understood. I hope so that you have understood this really well. If you have not, please do let me know in the comment section or in the chat right now, and I'll be there for you to help anytime. And then we will move on to the next concept, guys. Today's concept was very, very important. The live stream looks good. 84 people watched it till now. 3 minutes more and we are 1 hour. Well, so today we have understood how to insert, how to delete, how to extract the elements from the heap. The code will be given in the comment section. I will pin the code in the comment section of this video. Notes will be given in the description below. Link will be given there. And in the Telegram channel also we will update everything. That's all for this live session, guys. Thank you so much for watching. It was pleasure to teach you heap data structure today. I hope so that you have understood this really well. If not, then please do let me know in the comment section below. I'll try to clear your doubt as much as possible. If it is right now, if you have any doubts, please, I am looking at the live chat window. You can type anything you want to ask and I'll reply to you there. Apart from this, today's concept, I hope so that this is very, very much clear. Alright, guys, that's all, and I will be seeing you guys again tomorrow, same time, 7 o'clock, 7 p.m. Indian Standard Time. I will be available doing some new data structure, guys. Heaps is over, So we may start graphs, or before graphs I'll tell you something about vectors or ordered maps, unordered maps, and all of those things that you have understood. I hope so that this is very much clear. Today's class is also understood very well. Well, thank you guys so much for watching. Let us start our doubt session. If you have any doubts, please do let me know, otherwise I am also leaving. No doubts? I am waiting for your comments, guys. So today we have done insertion, extraction, deletion, increasing the value of the key. We have done heapify. Remember, heapify up, heapify down, bubble up, bubble down, extract, delete and insert. Well guys, let us close this live session. Without any further ado, thank you guys so much for watching this live session. It was pleasure to teach you today about Heaps data structure. I hope so that you will keep on coming and watching my live session. Keep loving my live sessions like this, and thank you guys so much for watching. With you people, when you people are there, when you people are talking to me, when you people are asking doubts, when the involvement engagement process is happening here, you see, I also get so much like from your guys, from your support. I get also motivated a lot to create more content like this, to create such content like this and come live daily for you for live sessions. So guys, keep on supporting. Thank you guys so much for watching. I will see you guys again with a new data structure, with a new day tomorrow, 7 o'clock Indian Standard Time. Do not forget to like, share and subscribe to our channel Coders Arcade, guys, and don't forget to press the bell icon also, so that you won't miss any future update. Apart from this, share this live stream as much as possible, so for those people also who really wants to learn DSA all for free, they can also watch it all for free. That's all guys for today's class. Do not forget to follow us on Telegram. Telegram is very important, guys. There we keep on posting our latest updates related to courses. If someone is, one more thing, if someone is feeling that this course is being stretched, or this course is taking a lot of time to get over, then you can join our crash courses. We are open to that also. We have our own batch. Next month I am starting the batch for DSA. For those people who really want to learn DSA direct from me, with asking bunch of doubts, with my interaction, a private different class, I can take daily to 2 hours. I will finish the DSA concept in 1 month, prepared for placements. Also in future I will also provide placement opportunities, guys. So we are about to start to conduct interviews also for different companies. So stay connected on Telegram channel, and this is very important, guys. Internships also very soon will be starting. So we are enrolling ourselves into the Indian skill development program also. So we are looking forward to start our internships as well. If you want to join my batch, in my batch I will provide placement assistance also, guys. So please do, if you really want to attend and get placement opportunities, you can join my batch. You can contact us on Telegram. You can contact us on our phone number that is already updated in our YouTube channel's bio, YouTube channel's contact information. Everything is there, guys. So if you are really interested to join our batch and finish DSA quickly and get placed, contact Coders Arcade, where I am going to teach you the whole DSA concept really well. And for notes and everything, I will only be providing. Oh, voice nahi aa rahi sir. Oh, voice nahi aa rahi sir. Okay. Hello. Yeah. Voice aa rahi hai mere ख्याल से. AK is a gamer. Hello. हाँ, I can. अभी आई क्या? AK the gamer. अभी आपको वॉइस आई? माइक तो मेरा ऑन है, बैटरी भी डाउन हो रही है, गाइस. Okay, we will end up this live session. Okay, yeah. So guys, thank you so much for watching. Am I audible? AK is a gamer. आप बताओ मैं ऑडिबल हूँ कि नहीं? अभी मैंने सब माइक चेक कर लिया है, मेरा माइक एकदम सही है, हेलो सब ठीक है, अभी आ रही होगी शायद मेरी वॉइस. Okay, so we'll finish up this live session guys, and do not forget to follow us on Telegram. हाँ sir, okay, हाँ, so do not forget to follow us on Telegram, and we'll post the mock interviews link also there only, and for placements and for placement assistance, contact us guys. Thank you so much for watching. Tomorrow again same time, 7 o'clock Indian Standard Time, I'll be there right again, back with a new DSA live concept. Stay tuned for more and subscribe to Coders Arcade channel. Thank you so much. I'll see you tomorrow. Bye bye everyone, and stay safe. Happy learning. So there we go. Bye bye. I think you have network issue. Yes, you're. Yeah, AK. All right. Everything is clear. My camera is about to die. So I'll see you guys tomorrow.